Alright, so once again, warm-up number 73. Number 1, it says make an input output table for f of x equals 1 over x and plot the points. Now, if you notice, this is something new. We're about to embark on a new concept. We're moving on this week, but next week we're going to get into these kind of functions. So I'm going to give you a soft intro today. Number 2, it says graph f of x equals x cubed. We know how to graph those. And then it says transform according to g of x equals f of x minus 4 minus 3. So by now you should know what to do for that. Number 3, factor. Part A is 2x cubed plus 4x squared minus 3x minus 6. And part B, 2x squared plus 5x plus 2. Do we know how to factor those? Yes, Mr. Q. Number 4, divide the polynomial with synthetic division. Have we been practicing for a couple of weeks now, right? Synthetic division? Yes. We got 4x cubed plus 3x squared minus 3x plus 14 divided by x plus 2. And number 5, solve the quadratic equation y equals 2x squared minus 4x minus 30. Now this one we covered, I want to say 2 months ago, something like that. So I'm going to go over that one just to bring it back. However, by now, you should be able to do number 2 and number 3, even number 4. So share with your neighbor, see where you're at with those. See if they have something similar to you. Alright, here goes number 1. It says, make an input output table for f of x equals 1 over x and plot the point. So on the side I'm going to write x, f of x, and for x I'm going to use negative 2, negative 1, 0, 1, 2. Our usual, yeah? Our bread and butter? Yes, Mr. Q. Alright. So basically I'm going to take this function and substitute all those values to get our f of x. So which is our first value? Negative 2. So here you go. I'm not going to write it in, I'm just going to show you. So if I was to write here negative 2, what do we get? 1 over negative 2, which is negative 1/2. That is correct. Next value, negative 1. I substitute negative 1 here, negative 1 here. I end up with 1 over negative 1, which is negative 1. I'm going to skip 0 for right now. I want to talk about that in a little bit. Let's go to 1. 1 here, 1 here. What is 1 over 1? 1. And the last one, which is 2. What is 1 over 2? 1/2. Now let me talk about the 0. So here you go. F of 0, 1 over 0. I end up with what? 1 over 0. Okay. However, let's see. We talked about the definition of fractions. I remember we got into this, I think it was the 3rd week of the school year. And I said, guys, here goes the definition for fractions, also known as quotients. And I said, it's the set of all fractions m over n. You guys remember that? They're like, oh, yes. Okay. Such that m and n are integers. That's what the z stands for. However, n cannot equal to 0. So what can't equal to 0? The denominator. Why not, Mr. Q? Because if it was a slope, check this out. A positive slope of a line goes upward, yes? A negative slope goes downward. A 0 slope goes flat. It's completely flat like so. However, we have one line that goes up and down like this that we don't know if it's going upward or downward. That's why this is known as undefined. The slope is undefined. That's why the 0 cannot be in the denominator. So I'm going to label this one undefined. Undefined. Alright, so let's graph that. Here we go. Make our coordinate plane over here. And we're going to space it out. We got 1, 2, negative 1, negative 2, negative 1, negative 2, 1, 2. All right, so here we go. Negative 2, negative 1/2. Negative 2, negative 1/2 is about right there. Negative 1, negative 1. Negative 1, negative 1, so it's about right there. 0 of x is undefined, so we can't plot anything here. 1, 1. 1, 1 is about right there. And 2 and 1/2 is about right there. Even though it looks kind of like sporadic and all over the place, it's not. It has a process to it. Check this out. So if I was to connect these with a curve, it would look something like this. And since I cannot plot anything on 0 because it's what? Undefined, I skip over here, go to the other side, and plot a curve on this side. Students, rational functions, students. We're about to get into these kind of graphs, which are funner stuff, yeah, next week. Yeah, we'll delay it for a little bit. I'm going to give you enough practice this week so you can get familiar with it, yeah? All right, let's move on. Number 2. It says, graph f of x equals x cubed, then transform it according to that. So let's see. It's a parent function, f of x equals x cubed. So before I graph it, tell your neighbor what 2 points is that parent function always going through. This one is always going through where? 0, 0, and what else? 1, 1. Yes, that is correct. So that one looks like this. Okay, that's f of x equals x cubed. There it is. However, we're going to move it according to this. Tell your neighbor, where do we move the whole thing? Where do we move the whole thing? All right, so I see that it's 4 to the right, yes, and 3 down, or my vertex is going to be at 4, negative 3. This one's going to be at 4, 1, 2, 3, 4, 1, 2, 3, so it's about right there. That means that other point's about right there, and my new function will be over here. Yes? Yes, here's the Q. All right, let's go to factor. Let's see, is there a GCF? No. Is it in standard form? Yeah, so let's group. 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 So, with that said, what's GCF for the first two? Tell your neighbor what's GCF for these two terms. 2x to the what? Second, we're left with x plus 2. What's GCF for these two terms right here? Negative 3, we're left with x plus 2. So my factors are x plus 2, and what's left over? 2x squared minus 3. All right, so far so good, yes? All right. Factor this one. Is it in standard form? Yes. GCF? No. 2 times 2, that's 4. 5 goes down here. What factors of 4 add up to 5? 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. I'm going to use a shortcut, yeah? Here we go. Make this into a fraction and this one. Can I simplify this fraction anymore? No. 2x plus 1. Can I simplify this fraction anymore? Yes, it becomes what? 1/2, which is x plus 2. Hands if you got that? Yes? Okay. And number 4. Now, you should be able to do number 4 by yourself, because we've been working on these, yes? Here goes the process one more time. Why, Mr. Q? Because we're going to need it a lot for today's session. We're moving on, yes? So here we go. What is the first thing we check? Standard form. Is this in standard form? Yes. Anything missing? No. Is this in standard form? Yes. Anything missing? No. So we set this equal to 0, minus 2, minus 2. So my divisor is negative 2. Coefficients, 4, 3, negative 3, and my constant of 14. Bring down the 4. I'm going to go a little bit faster now that we've got plenty of practice. Negative 2 times 4 is negative 8. Combined, that's negative 5. Negative 2 times negative 5 is 10. Combined, that's 7. Negative 2 times 7 is negative 14. Combined, that's 0. So, what is my polynomial that's left? We started with an x cubed. This is a what? 4x squared minus 5x plus 7. And no remainder. However, how would I write this as a polynomial? What was it before? X plus 2. Yeah, x plus 2. Right? Came from here. Okay. Before I move on, though, what if I give you this? Any of the two polynomials that we have there? What are the two polynomials? All right, so this would be 7x cubed, 6x squared, minus 2x plus 1. Is that correct? And this one would be x plus 3. Does everybody see it? You're like, I don't see it, Mr. Q. Then set it equal to x. And then they need to be equal to 0. Yes. One more, just for the sake of it. Take over the two polynomials that we have there, please. All right. So, negative 2x cubed plus 6x squared plus 5x plus 4. And if we divide that by x minus 5. Yes? All right. Number 5. And last but not least, hopefully you remember this one. If not, what is the first thing we do when we solve quadratic equations? They need to be equal to 0. So we got 2x squared minus 4x minus 30. Next, is it a standard form? Yes. Is there a GCF? TCF? Yeah, 2. We're left with x squared minus 2x minus 15, and all that equal to 0. All right. Next, can we factor this term in here? I mean, this polynomial. Yeah, negative 15, negative 2. Factors of 15 that add up to negative 2. Negative 5 and 3. So my factors are x minus 5 for that one, x plus 3 for that one. Bring down the 2. Now that equal to 0. Next, am I done? No, to solve we need to set each one equal to 0. 2 equal to 0, that's not true. Then we got x minus 5 equal to 0. Let me erase this, parentheses. And x plus 3 equal to 0. So, plus 5, x equals 5, minus 3, x equals negative 3. These are my solutions. X-intercepts, zeros, and roots. You guys remember these? Yes? All right. So, in the past, we know why there are solutions, why there are x-intercepts, why there are roots. Let me reiterate why there are zeros. Why are they zeros, Mr. Q? Well, because if I was to take the original equation, this one, and I would write 2 parentheses squared minus 4 parentheses minus 30, and instead of x, I substituted these values, guess what I would get? Wild guess? Yeah, this is positive 5. Yeah, I would get 0, 5. So let's see. What is 5 squared? Times 2, 50. Negative 4 times 5, negative 20. Bring down to negative 30. Combine, negative 50. What is 50 minus 50? That's why these are called zeros because they make the equation equal to 0. They make the equation equal to 0. Okay. The reason I'm emphasizing on that, again, bringing it back, is today we're going to combine everything we've seen so far. Yes? It's going to get really fun in about a minute. Yeah? You guys ready for a Monday? Let's go! Let's go! We got this. Here we go. Our agenda for today, warm-up number 73. We're moving on to a new concept known as polynomial equations and zeros. Our home plate for tonight is pages 348 and 349, evens only. Make sure you go to Canvas. In Canvas, you're going to find out on our home page on modules, when you go to modules, there's a new one. I included a new one known as polynomial equations. Click in there, and you're going to find pages 348 and 349 in there. And there's no asynchronous code. Somehow I've been having issues with Nearpod. It's been spinning. I don't know what's going on. So no asynchronous code tonight. However, you know where to go, right? YouTube channel, yeah. Also, reminder, when you're not here, I'm always on at what time? 1:30, okay. Good thing, so like that you'll probably be fine, right? Alright, so last weekend, no home plate. Hopefully all of you got caught up with all your work, yes? Alright, good. Woo, let's go. And our home plate for tonight, 348, 349, evens only. Y'all ready? Alright, here we go. You need a Cornell note. You do need a fair model for today. We're moving on to a new concept. Here we go. Our objective for today, I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. I can identify rational zeros of polynomial equations. And as we continue getting to the meatier portion of the school year, I like these next concepts that are coming up because they're part of the pre-calculus, I guess, group that you're going to need for the next course. And it just makes it make sense, I guess, if you want to call that. So once again, today we're identifying what? Rational zeros. I'll talk more about that. But something that should sound familiar by now would be the word polynomial, right? Yes, polynomial equations. But today we're going to kick it up a notch and make them equations. All right, here we go. Polynomial equations, what are they? Polynomial equations are two-variable equations that have monomials or some are different than monomials. Hopefully that sounds familiar. You guys remember the definition for polynomials? Monomials, some are different than monomials, yes? But now we're looking at two-variable equations. Okay. Once again, two-variable equations that have monomials or some are different than monomials. Example. Y equals x squared minus 3x plus 2. Y equals x times x minus 2 times x plus 3. All right. So let's see the definition again. Polynomial equations are two-variable equations that have monomials or some difference in monomials, which is known as polynomials. Let's look at the first equation. Do we have a two-variable equation? Yes, two different variables, and it's an equation. Do we have a polynomial? Well, this looks like a polynomial. Does it have monomials or some or difference in monomials? Yes, Mr. Q, there it is. How about this one? Two variable equations, yes, two different variables, and it's an equal sign there, yeah, so equation. Does it have monomials or some or difference of monomials? Yes. But from there, I think we went straight from y, and then we changed that to what? The y became what? Yeah, f of x. So this is f of x equals 2x cubed plus 4x squared minus 3x minus 6. But the f of x, we know it's considered a y, so it's still a two-variable equation, and here are some more difference in monomials. Okay? But today, in your textbook for your home plate, since they're talking about specifically about polynomial equations, they changed the F to the letter what? Very good. P for polynomials. P of x equals x to the fourth, negative 4x cubed, negative 7x squared plus 22x plus 24. And they changed that for the purpose of keeping it within the polynomial equations. Polynomial equations. Okay, so according to the definition, those are two variable equations, yes. And they have monomials or somewhat different than monomials, yes. Okay. So, now that we know what polynomial equations look like, let's find out what are not polynomial equations. Here you go. I see an x squared. I see a 2. Negative 3x to the fourth plus 2. X squared minus 3x plus 2. Now, hopefully, it's obvious why all of those are not polynomial equations. Talk it over to your neighbor. Why are those all not polynomial equations? Did everybody see the obvious thing? No equal sign, yes? So if it doesn't have an equal sign, that means that it cannot equal to a different variable. So that's why no equal sign, no two variables. So write these hashtags down. Hashtag equations only. Hashtag two variable equations. And hashtag various terms for polynomials. Alright, so today we're going to be using a theorem. It's extensive, but I'm going to break it down so that you can understand the theorem and use it for tonight's home plate. We good? Yes? All right. So before I talk about the theorem, let me talk about two terms. The first one, zeros, and the second one, rational. Zeros. By now, do we know why we end up with zeros for quadratic equations? Tell your neighbor why they're called zeros when we come to solutions of quadratic equations. And let me go back to the warm-up. Talk it over to your neighbor, let them know why those are known as zeros. Why are those known as zeros? All right. Let's see. I think good conversation over here. Daniel, why are those called zeros? All right, help them out. Diego. Lynn. Okay, here goes again. When we solve a quadratic equation and we end up with these here, they're called zeros, because when we substitute them into the original equation, we end up with 0. That's why these are called zeros, as I explained it earlier on the warm-up. Here it goes one more time. When we solve a quadratic equation, at the end we end up with x equals something, x equals something. Those are known as zeros because if we take those values, substitute them into the original equation, what do we get at the end? 0. That's why they're called what? 0. Tell your neighbor again and see if they see it now, please. Explain it to them one more time. All right. So let's say I gave you the equation. Don't write this down. 6x squared plus 11x plus 3. And then I asked you to solve it. So you set it equal to 0, yada, 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 and at the end you get x equals something and x equals something. These are known as zeros. Tell your neighbor why those two would be named zeros. Why are they called zeros if we get a solution with some numbers there? Let's see. Daniel, why are they called zeros? Yes, because when we substitute them into the original equation at the end, we get a 0. Is that clear enough? Yes? Okay. Enough of those zeros. Okay, we're clear with zeros. Now, the easiest question. What is a rational number? Tell your neighbor, what is a rational number? Mind you, this is like elementary stuff. But by now you should know what a rational number is. Alright, let's see, good conversations. I'm going to pick Mr. Q, just for the sake of time. Any number that can be written as a fraction. 23 is irrational because I can write it as what? Over 1. Yes, Michael Jordan. Yes, thank you. Over 1. How about 0.25? Can I write that as a fraction? Yes, 1/4. All right. How about 0.6 bar? Can I write that as a fraction? Yes, 2/3, and so on and so forth. Any number that can be written as a what? Fraction. So today we're going to be talking about rational zeros. That means at the end, when you end up with an answer, any number that can be written as a fraction can be substituted in there and get 0 at the end of the equation. Okay. We good yet? All right, let's crank it up. Don't copy this. I'm going to give you a theorem. Don't copy it because I don't want you to get confused. And it reads, if p of x is a polynomial function with integer coefficients. Now, by now, that should register pretty well. Here it goes again. If p of x is a polynomial function, okay, I can think of a polynomial equation, okay, with integer coefficients. Can you picture the integer coefficients? Okay. And if m over n is a 0 of p of x, or in other words, p of m over n, that is equal to 0, then m is a factor of the constant term. Does that sound familiar? Constant term? Yes. Of p of x. And n is a factor of the leading coefficient. Does leading coefficient ring a bell? Yes. You're saying, what does all that mean, Mr. Q? Well, write this down, example Q. I'm going to go over the theorem as an example. So like that, it's easier to understand. So example Q, I want you to copy this. I want you to copy constant over leading coefficient. I'm just going to use the initials LC. So basically we're going to make a fraction with a constant and the leading coefficient. From there, we're going to write it as factors. All right. That's what that says. So here it goes. Ready? I'm going to give you an equation, and you're going to write me this. Here's your equation. P of x equals x squared plus 5x plus 6. All right. So by looking at it, by now you should know which one's the constant and which one's the leading coefficient. We've been hammering this all year. Talk about you never let them know what is the constant and what is the leading coefficient. Okay, once again, for the sake of not putting anyone on the spot, my constant is a number without any variable, so that one goes right there. The leading coefficient is the number that's multiplying the first term and the first variable. What's the leading coefficient here? 1, so that goes right there. So we're going to be making a fraction with a constant and the leading coefficient. Now that I made my fraction, now I need to come up with factors of this. Question: what factors give me 6? What two factors give me 6? 1 times 6, very good. What else? And 2 and 3. So all these are factors of that. Do I need to find the factors of 1? No, because 1 times 1. That's what that theorem says. What does the theorem say? It says all of that. Rational zeros theorem is that we make a fraction out of the what? The constant and the leading coefficient, and these are my factors. However, check this out, put a little plus and a minus. And what they're saying that any of these numbers could be a what? A 0 for the equation. Do we know what a 0 is? Yeah, that if we substitute into the equation, it makes it equal to 0. Yes? Let's do one more. What if I gave you example omega q, and I gave you p of x equals 2x squared plus 10x plus 12. Use the rational zeros theorem so you can write me your fraction. Find the factors of our possible zeros. This is 10. Sorry. All right, turn to your neighbor, let them know what you wrote for your fraction first. Should have written what? 12 over 2. Yes, 2 is right here, and the 12 is my constant, which is right there. Okay, next, factors. Factors of 12. What are factors of 12? 1 times 12, 2 times 6, and 3 times 4. All these are factors of 12. But now we have a 2 in the denominator. So what are the factors of the 2? 1 times 2. All of these are my possible zeros. Now, why did I leave this in the denominator, not this one over here? Because we know that 1 over 1 is 1. And that stays as a 1 on all of them. But now that we have this, we can combine stuff like this. Look up. I'm going to start with a 1. What is 1 over 1? 1. 2 over 1? 2. 3 over 1. So these will stay the same, yes? But then, what is 1 over 2? 1/2, that would be another possibility. 2 over 2? We already have it. How about this one? 3 over 2. What else? 4. What is 4 over 2? We already have it. What is 6 over 2? We already have it. What is 12 over 2? We already have it. So the only thing that we would add to this list would be what? These two fractions. All right. So from 1 to 5, is this doable? Yes? Okay. So once again, the only thing to do is to get the constant divided by the coefficient and make it into a fraction. And then find your polynomials, your factors. Are you all ready? Put this into practice. Copy this, example number 1. Let's see how this is going to work. Copy this. Copy the instructions so you can have at least the instructions for the first one, and it reads, find the rational zeros of the polynomial function, then write the function as a product of factors. They give us f of x equals x cubed plus 2x squared minus 19x minus 20. Copy that. Ready and go. All right, the instructions read, find the rational zeros of the polynomial function, then write the function as a product of factors. And they give us our polynomial function, f of x equals x cubed plus 2x squared minus 19x minus 20. So the first things first, let's write our fraction. Ready? Here we go. So I would write constant over LC, or leading coefficient, yes? All right. Say never the fraction, please. Yeah, negative 20 over 1. Yes, negative 20 is right here. It's our constant. Leading coefficient is here, which is 1. Okay. However, we need to find the factors of what? 20, yes? All right, find all factors of 20. Write them out, please. So, 1 times 20, 2 times 10, 4 times 5, and then they repeat the other way around, okay? And put a plus and a minus. All right. We good up to right there? All right, so let's get to work. They want us to find the possible zeros. How do we do that? Write your utensils down, look up to the screen. Look what I'm going to do. I'm going to start by testing to see if positive 1 is one of the zeros. Remember, that needs to make it equal to 0? Check this out. I'm going to start with positive 1. Pay attention to this part. Here we go. Positive 1. Let me start with blue. And I'll leave the negative as a red. Positive 1. Does everybody see what I'm doing? 1 times 1 is 1, combined that's 3. 1 times 3 is 3, combined negative 16. 1 times negative 16, that's negative 36. Check this out. Since I get a remainder that is not 0, that's why this one cannot be my 0. So what does the remainder have to be? 0. So you're saying, so if positive 1 didn't work, what do I do next, Mr. Q? That is right. Let's try negative 1. You're like, oh yeah, Mr. Q, I like these, right? Bring this down. What is negative 1 times 1? Negative 1 combined, that's 1. What is negative 1 times 1? Negative 1 combined, that's negative 20. Negative 1 times negative 20 is positive 20. And what do you know? This is our what? 0. Copy that so far? Good thing you practiced the warm-up, right? And the synthetic division. Yeah? Okay, good. Here it goes again. You were given a polynomial function. You made a fraction using the constant and the coefficient. From there you found all the factors. There they are, plus or minus. From there we used synthetic division to find out which one was a 0. We started with positive 1. That was not, because we had a remainder. But then we did negative 1, and that was because we ended up with 0. But now I need to write my function as polynomials. Here we go. Write your utensils down, look up to the screen. I'm going to start with f of x. But instead of writing this polynomial, now I have a different polynomial down here. So remember what this polynomial is right here that I have left. Okay, so this polynomial left here is 1x squared plus 1x minus 20. Right? Because we started with x cubed, didn't we? That means this is x squared. Times, look up, what is this one? How can I write that as a polynomial? X plus 1, that is correct. Does everybody see why? Because this one was before it was x plus 1, we set it equal to 0, and then we solved to 1. Are we done? No, look at this one. What can we do with this? Tell your neighbor, please. What can we do with this? Factor. Because they want us to write it as factors. So, negative 20, 1. Factors of 20 that add up to 1. What is it? Two numbers that multiply to give me negative 20. Negative 4 and 5. So my factors are x minus 4, x plus 5, bring down the other factor, and all that equal to f of x. This is our home plate for tonight. And what does that mean, Mr. Q? That each of these three factors could be a zero of the equation. Do we know how to do that? 7 equals to 0 and such like that. But that's as much as we're going to do tonight. Fairly simple, yes? Let's do another one. Copy this one, example Q. Example Q is g of x equals x cubed plus 7x squared plus 16x plus 12. G of x equals x cubed plus 7x squared plus 16x plus 12. Once again, we need to find factors, write it as product of factors at the end. You need your fraction. Constant. LC. Okay, before you get going with the work, tell your neighbor what your fraction is up to right there. Yeah, 12 over 1. So, factors of 12. 1 times 12, 2 times 6, 3 times 4, plus or minus. All right, so with blue, we're going to start with what? Positive 1, yes? All right. All right, Nano, what do I write here, Nano, to start my synthetic division?
1, 7, 2, 12.
All right, so let's see. 1 times 1 is 1, combine that's 8. 1 times 8 is 8, combine that's 24. 1 times 24 is 24, combine that's 36. It's a remainder, so that means this is not a 0. Next, I'm going to try what? Negative 1. Negative 1. 1, 7, 16, 12. Bring down the 1. 1 times negative 1 is negative 1, combine that's 6. Negative 1 times 6 is negative 6, combine that's 10. Negative 1 times 10 is negative 10, combine that's 2. That's a remainder. So guess what? This is not a 0. What do we do next? Pablo, what do I do next? Yeah, the next number, positive 2. 1, 7, 16, 12. Let's see. 2 times 1 is 2, combined that's 9. 2 times 9 is 18, combined that's 34. 2 times 34, that's 68, combined that's 80. Well, guess what? That's a remainder, so that's not a 0. Next, which one shall I try? Negative 2. 1, 7, 16, 12. Negative 2 times 1 is negative 2, combined that's 5. Negative 2 times 5, that's negative 10, combined that's 6. Negative 2 times 6, that's negative 12. And guess what? Here's our 0. So, g of x. Who can give me the polynomials before we factor? Who's got it? One x squared plus 5x plus 6. And how about the other polynomial? This one, guys. That would be what? X plus 2, yes. Can we factor this one? Let's try it. 6, 5. What factors of 6 add up to 5? 2 and 3. So my factors are x plus 2, x plus 3. Bring down the other one, x plus 2. And all that equal to g of x. Woo, let's go. From 1 to 5, I'll come to borrow you with these. 1 to 5, 5, 5, 5, 4. Yeah. Yeah, you're like, Well, this is kind of like what we did on warm-up, pretty much, yes. Have a good one, guys. Enjoy your home quiz. See you guys tomorrow. Bye.